So let's see the capacitors. I'm going to show you how to test and check the capacitors, all kind of capacitors. Okay, so let's get started. So I will show you how to check capacitors using two methods. The first method is by selecting the diode option, and the second method by selecting the capacitor option. Okay, so let's begin with the first method by selecting the diode option. Okay, so here we have a tantalum capacitors that we're gonna check. So to check this capacitor, basically we should determine the positive terminal. The band means positive terminal. So let's check. So as you can see, we have a reading in the multimeter. So the value increase and decrease means the capacitor charge and discharge means this is a good capacitor. Okay, if you get a continuity or a buzzer means the capacitor is bad. So let's check this capacitor also. This is an electrolytic capacitor, so let's check it using the same working principle. So we have the value in the multimeter increase and decrease means the capacitor charge and discharge means this capacitor is good. Here also we have another tantalum capacitor. So as you can see in the multimeter, the same, we have a reading here that increase and decrease means this is a good capacitor. Okay, so let's check also this electrolytic capacitor. So let's check. Okay, here we get a reading in the multimeter that increase and decrease, as you can see, means this is a good capacitor. Now let's pass to the second method by testing the capacitance of capacitors. Okay, now we choose the capacitor option. As you can see in the multimeter, we have a nanofarad, but we have here auto range. Okay, so the multimeter will check automatically the capacitance without selecting a range. So let's begin with this capacitor. We have 220, as you can see, 220 microfarad. Okay, 220 microfarad. So we should get 220 microfarad. But sometimes we cannot get exact value. We have 220, about 220. We have 249. So this is a good capacitor. Okay, because you cannot get the exact value. Okay, so here as you can see the unit change automatically to microfarad. Here let's check this capacitor. We have 227 in the capacitance, 227. So as you can see in the multimeter, so we have 200, about 227. We have 249. It's okay. Okay, so the capacitor is good. If you get a continuity or you hear a buzzer, means the capacitor is bad. So let's check this capacitor. Also we have 220. Its capacitance is 220 and 6.3 volt. So let's check. Always you should respect the polarity of the capacitor because the capacitor is a polarized component. Let's check. Good. We have, as you can see in the multimeter, about 220. This is a good capacitor. 226, good. This is a good capacitor. So as you can see here, for this capacitor, we have 220 and we have E. We don't have a voltage, but we have E. But for this, we should use the capacitance code table. The E means 25 volts. E refers to 25 volts, as you can see in the code table. But in this capacitor, for example, we have the capacitance and voltage. So let's check this capacitor. Also, we have here 110 volts. So we should get 100 microfarad in the multimeter. So let's check. So we have 91.4, about 100. This is a good capacitor. So now let's check the ceramic capacitors. Okay. Using the same working principle, you should get a value in the multimeter, the value increase, as you can see. We get a value. Means the ceramic capacitor is good. If you get a continuity or a buzzer, means the capacitor is damaged, is bad.